Good afternoon. My name is Peter Kirpik from HERE Technologies, and I'm going to talk to you about the Open Location Platform, which is basically the idea to bring together location with real-time sensor data. And if you look at the journey that the world has been taking, and we have a couple pictures here where you see, like, we started it off with maps, like, ages ago. And up to a couple years ago, we were still at the level where we're talking about a map that gives us a road from A to B. If you look at what's happening, especially in the area of autonomous driving, but above and beyond in the area of transport, logistics, any kind of location-based services, the demand for much, much higher precision in positioning yourselves, goods, and whatever you are tracking is increasing. It's going down to centimeters, and maybe beyond that, even to millimeters when you look at real-time scenarios like the one we just saw from Amazon Go. So that is a journey that's happening, and that journey impacts the way you as a developer can build an application. So what we have, above and beyond that, of course, we have all these mega challenges that are coming to us, okay? Whether it's handling large cities. We were going to have about 1,500 mega cities in the next 25 years in China, in Asia, in areas across the world where we have 10 million plus people living. Whether it's having a higher degree of sustainability, what you see, for example, happening in Dubai, where the whole city becomes a space where the whole city is embraced as a smart city with urban mobility, transport, etc. Whether it's the area of on-demand economy, where the drone will kick in the next years, where drones will start delivering goods. Once you just think about a scenario like the drone scenario, when a drone travels at, let's say, 50 miles an hour or 60 miles an hour across a city, the average time to actually deliver a good across a mid-sized city is going to be in the area of minutes. You'll have travel times of minutes, and what you need between those endpoints, like taking something like a pizza or whatever, and bringing it to whatever endpoint, you would be looking at scenarios where you have make 3 minutes elapsed time. 3 minutes of elapsed time, and in between precisions of centimeters where the drone picks up the good, goes somewhere, doesn't knock into a building, for example, and then drops it into a very specific spot on the street or maybe a dedicated location for drones and puts it down there. All of these scenarios that you're seeing here demand for a very high degree of precision in location. So location becomes basically a native element in every piece of business that we're doing. Every e-commerce business, if you think of going above and beyond an address, think of yourselves getting goods delivered at home, and then you're not at home, and you have the usual scenario where the person from whatever company comes back 3 or 4 times, then he starts dropping a note, you go to the local post office. All of this clumsy stuff is going to go away, and goods are going to be delivered, maybe perishable goods, are going to be delivered to you at the point of where you are. So basically, somebody's going to tap on your shoulder and say, here's your, salads for tonight, or, whatever, printer cartridges you just were waiting for because you have to print out something on the fast track. That is going to come, and that demands, again, for an extreme precision in location, at the same time, very low latencies. And a lot of industries are going there. If you see here, the industries, I just picked a few, whether it's an insurance place, where we're looking at user-based insurance scenarios, whether it's business intelligence, geographical systems, whether it's in wearables, where we have seen first waves of wearables. We're going to see much more of that. Wearables are going to be something that is going to send a richness of sensor data to the cloud. Whether it's in the industrial IoT space, where above and beyond all the on-demand supply chain that have been unfolding in the next 20 years, we, for example, at HERE still see that the industry is tracking or having a huge problem with tracking goods. Still goods are in places where they should not be in the industrial environment. And there, again, you want to know by the meter where these things are. So the challenge we're faced with is that we have these zettabytes of data, of sensor data. This is just one number. You can't find any kind of other number. These are all very, very large numbers. And the art will be to leverage that sea of sensor data for those location-specific scenarios in a way that you create value. I heard the other day from an analyst from one of these large analyst houses who said, data without usage is absolutely has zero value. So if you don't know how to extract value out of your data, you can store them, you can kind of massage them, whatever you want. You're not going to extract value. You got to have a usage scenario and map the data against your usage scenario. So what we do at HERE, and this is basically something that we're unfolding as we speak right now. We're going to have a general availability of that platform early next year. Is a platform that on the one hand allows to kind of like get sensor data in at scale. We're working very, very closely with the automotive industry here. We're talking on millions of data sets per second coming in from all the cars. Any kind of modern connected car today can propagate up to 250, 300 different kind of sensor data to the cloud. So imagine those data coming in, getting aggregated, cleansed, filtered. And then what's happening is two things. Of course, we have to do what everybody else to do. Apply machine learning, artificial intelligence processes to actually identify patterns and create business value on top of these data. Doing statistics and all of that. But second to that, you also have to, when you talk about location-based services, you have to go and find out where am I? Am I geofenced in a certain region? What kind of attributes are valid at that point where I am, where my goods are? Is there like a hazard warning going on? Do I have to watch out on, traffic conditions? Is there any kind of level of pollution in that space, right? So that's what we in that platform provide. So the open location platform allows you on the one hand to kind of carry very large amounts of sensor data in and do the usual cleansing and aggregation. But on the other hand, it allows you to really map match, as we say, those sensor data and get a clear idea on routing, rendering, and all of these services that you need to build a location-based service. And then, of course, you can scale this out. And second to that, you can, of course, then reach any kind of endpoint, whether that's a mobile phone, whether it's a web page, whether it's any kind of edge device at the edge. Underneath, we have what we call the reality index. And that is basically clicking a couple times here. It's a database that allows you to actually read any kind of location-based attribute that you need and that you can augment as well in the context of your business problem. So things, basic things like, addresses, places in the surrounding. We have about 160 million places in our database, but also any kind of attributes like pollution attributes, weather attributes, attributes that come from a city, stuff like, where's garbage collection going to happen next week on the left side of the road or the right side of the road. That might matter if you want to have a robot running across the street, or if you want to be sure that the street is not going to be hampered by garbage along the street, stuff like that. So we have that very rich set of attributes. In some locations and countries, we come up with after 750 different attributes on the map that you can, as a developer, grab and inject in your business application on the fly. So to kind of summarize it, what we're looking at what we call this open location platform that allows to kind of inject all these data and gives you a richness of services, anywhere from a data marketplace to a developer environment and developer community, all the way to shrink wrap, ready-to-go service and solutions that you can use and inject in your application. Of course, it comes with the usual user-based user management, tenant management that allows for data isolation and all these kind of things that you kind of have a robust, future-proof platform. What we're creating right now, and we are working on an open location beta program right now. We're working with a set of large OEMs, automotive companies, and other companies behind the scenes to actually create a certain degree of data gravity. As you all know, our platform doesn't make sense if it comes as an empty shell. So you want to have an initial set of rich services and data sets already ready to go before you go into a GA. And that's happening behind the scenes, where we're starting to kind of have the flywheel spin between data gravity and active developers. And so the model that we're undergoing right now is to go from internal developers, heavy use of internal developers, to a platform when it goes GA to have a richness, and then open the kimono basically for external developers. What we're tackling from industry's perspective is, of course, a very large set of industries. And I'll bring a couple examples down the road from the automotive industry. We're looking at fleet management, we're looking at utilities, we're looking at public sector, cities, huge demand from cities. If you look at what happens in the cities right now, every city has kind of the smart city label somewhere going on. But cities are not native IT organizations. They have hard problems in taking, developing that IT muscle and skill. So they are looking for places to actually host their needs and their applications, and that will be definitely a place that they can go for. I'm going to give you a couple examples that are in the making as we speak, and you're going to see this unfolded in 2018 in some of the automotive products that you see in the market. And a couple examples here that we're working on. Real-time traffic, lane precision traffic. A lot of you have already seen this when you're on a highway, and the highway has 4 lanes, and there's on one specific lane, mostly it's one exit lane, it shows traffic and all the other ones are free. If anywhere the routing algorithm picked that up and says, you got to go, you're not supposed to go, although you're going straight, it's pretty annoying. So you want to have lane-specific travel and traffic there, so that you only pick the one lane that you really actually use. So working on these kind of things makes it much more cumbersome, because guess what? Think of Los Angeles, where you have highways with 7 lanes. You got to track every lane separately, which gives you precision levels of meters, sub-meters to actually get that triaged and sorted out. Let's take another example, which you see a better picture here. On-street parking. For those who don't know, if you have the ultrasound sensors on the car, those things are always on. They're always on, whatever you drive. So while you drive in the city, the car automatically picks up every parking slot on the side of the road. And it can pick up the beginning, can pick up the end, exactly knows how big that thing is, can propagate this to the cloud for 2 purposes. One is doing statistics, so you understand roughly in the city what kind of parking availability you have. Second to that, you can sell that. Imagine you're driving in a very crowded city, and you're in a hurry, you go I need this parking spot right now. Is there something in the vicinity? You press your dashboard or your app, here goes to the cloud, picks up a parking slot in your vicinity. As the cloud knows how big your car is, can exactly pick the right slot, and says, if you turn around left here, there's a parking spot, and by the way, due to statistics, I know it's gonna be free by 95% chance. You pay, you go yes, I'm gonna do this. You pay a little amount of money, and here you go, and you get your parking spot. I bet that downtown New York City, at one point in time, people are willing to pay a lot of money for that kind of service. Right? If you look at what parking is in New York City or in very large cities like Paris, etc., parking spots can go up to tens of euros easily. Hazard warning, slippery roads. From the sensor data of the car, you can extract easily, for example, are these wheels are spinning? Is the car basically aligned with the wheels all the time? If not, there might be some slippery road ahead of you. Get those data to the cloud at the level of hundreds of meters, and you can exactly say to somebody who's driving behind, expect the slippery road ahead of you. It's going to come. Warning, slow down. Or proactively go into and braking the car when you're driving in a semi-autonomous mode. Road sign recognition sounds like not really cool, because you go yeah, we all have these cameras in our cars and they recognize the signs. Yes, that's what they do in the car. How about propagating this to the cloud and giving it back to all the cars in the vicinity? Why does that make sense? Think about an autonomous car that is driving, let's say, 100 miles an hour. And all of a sudden, there is this road work, this construction road work. The car doesn't know about it. That autonomous car today doesn't know about it. Here comes, it goes out from 100 miles an hour, goes down to, let's say, 30 or 40. That car is going to go and do a hard brake. You're going to maybe smash into the window if you don't have your belt on. And instead of that, what you want is a proactive warning. You want that car 2-3 miles ahead of the curve to know, wait, there is a moving construction site just for a day here. We know about it. That's the new speed that is valid in that region. Why don't you take a breakdown already, go into a smooth transition, and then accelerate after that? Might be also about lane closures and all these things. All of these things can be picked up by cars today, by no means very, very easily propagated to the cloud, propagated back as a result to all the cars in the local area. So these are a couple examples on things that we are unfolding right now as we speak. That all also works, of course, in any kind of IoT scenario. I gave you a couple examples here that are examples out of the world of automotive, but think of this being valid in any kind of aspect of IoT. If you look at logistics scenarios have the same thing. Drones that are going to come into play, you're going to see these mixed scenarios. For those who have seen this at CES last year, there were more than one beautiful examples where you're going to see a combination of a van and a drone delivering goods, the drone taking small packages up to 1 kilogram, the van going for the bigger ones. You'll ask for a very, very subtle, complex scenario that has a lot of location aspects, a lot of sub-second real-time aspects that have to kind of come together to kind of build such a scenario. So logistics and all of these aspects and business solutions that are needed there have the same needs. So if you look at this spider web here, we just kind of carved out the aspects that we're tackling. We're looking at an industry-grade, or call it enterprise-grade level of location-based services that we want to provide from HERE Technologies. Of course, all of this is hosted on AWS, so we're also using the richness of AWS as a platform for us to host the data. We're looking at pretty much petabytes of data that we today from HERE Technologies have on AWS. And so that also allows you as a customer, when you work with HERE Technologies, to actually have a ubiquitous service across the world. And so we're looking at reliability, availability. We're looking at the data completeness and richness. We're looking at data freshness, which isn't that easy when you're thinking that some of these round-trip scenarios, for example, in the automotive industry, they need sub-second response time. One of the very critical scenarios that we're looking at is, for example, when a car heads towards the rear end of a traffic jam. Very classical scenario, very prominent these days in large urban environments. People come in from the suburbs, drive on the highway, especially here in Germany, come in, and again, let's say 100 miles an hour or 80 miles an hour, here's a traffic jam that has piled up that has come to a full, complete stop. Classic accident where, maybe a truck or a car dumps into the back end of a traffic jam. If you want to give those guys an early warning above and beyond the range of the radar, that has to be sub-second or second at max. Otherwise, it's useless. You don't need it. You're going to see it anyway. So if you want to do this, like 300, 500, 800 meters ahead of the traffic jam, you're talking about a sub-second scenario to actually propagate this back to the car. So data freshness, accuracy, and of course, finally, ability to scale is very, very important. So what we do right now, we're basically building up this platform. That platform will have, for example, what we call an HD map, which is a map that has 15 centimeter and less precision on the map. So that allows you to really position something really not just on a road or at a, let's say, address, but it will allow you to have positioning basically in a lane level, tracking level, precision that you might need for some logistics scenarios. At the end of the day, this is a joint exercise, so we're working with a lot of large industry companies here, telcos, automotives, telecoms, to actually get this going. And it's a joint exercise, and of course, we're looking forward to embrace all of you, and you as a developer on this platform ongoing from end of first quarter next year. Thank you very much for your attention.